So, welcome to a continuation of ShockWeek. We are Monday. We had Nihad El Sharif and myself talked about ground fault circuit interrupters. We went in depth in that discussion for GFCIs and hopefully and that's available on my YouTube channel, so you guys can and everybody can look at that. And if you have any questions on that content, I put Lucas's story on that in that event as well, down in the notes below in the YouTube channel. I'm just trying to get organized because I'm just trying to think here. So I'm going to turn off this Menti code. Well, I'll leave it there for a couple more minutes. Yesterday, we had I had Matt Hussey with us, and we talked motor control centers. There was a lot of stuff about electrical safety. MCCs are a pretty dangerous piece of equipment. There's a lot of justified energized work that goes on in that equipment because of troubleshooting and things of that nature, motor control circuits and whatnot. So we talked a lot about the shock safety and arc flash safety. So if you're not aware, check that out. And also, I will let you guys and everyone know and gals know on the phone, there is a electrical safety workshop. I don't know how many of you online are members of the IEEE, Institute for Electrical and Electronics Engineers. But I just want to make sure you are aware that there is an event every year called the Electrical Safety Workshop. So the Electrical Safety Workshop is an event that occurs annually that I think is really, it is a moment in time when a lot of our electrical industry, a lot of your big organizations, your DuPonts of the world, your Eatons, and all of our competitors, all of the Square Ds, GE, Siemens, you've got your Exxons, your General Motors, your Fords and Chryslers, all of those types of organizations get together and they talk about advancing the electrical safety culture. So there's technical programs. We have a lot of our IEEE 1584 meetings, 1814 meetings on maintenance. There's a lot of really good technical standards and codes meetings that occur there as well. There's a technical program with various technical sessions that you can attend. This is again, if you just search IEEE Electrical Safety Workshop, you'll find this site. You can register for the next event, which is going to be in Texas. I can't remember the locations, the city. I mean, I'm on the committee, but there's different committee meetings. There's different working group meetings. So this, I believe, was our last meeting, which was out in Reno. But we talk about things like the Electrical Safety Committee. We have technical subcommittees, and we have various types of subcommittees that will meet. So there's working group meetings on, like, for example, 1814, which is the recommended practice for electrical system design techniques to improve electrical safety. That's safety by design concepts. There's the risk assessment. We've got 1584.1, which is the deliverable requirements for an arc flash hazard study. So there's a lot of really good like-minded people focused on electrical safety, and there's a lot of good topics and committee meetings out there. So I just wanted to at least make you aware of that as we move into this discussion of I'm going to turn those off, of electrical safety. And basically today I am going to be talking about marinas. So that's my focus, is on marinas. So hopefully we will be able to turn that Menti code off and get this session moving. All right, so Menti is now off. We are now rolling, and welcome to our focus on marinas. So a marina. So the first thing I want to do is say I'm going to reference the 2020 version. 2020 version of the National Electrical Code. So that's my discussion point today. And we'll be looking at code requirements. We'll be talking about different solutions and design solutions to accommodate some of the new requirements that you'll find in the NEC. I need to get rid of the studio mode. All right. And I'm just going to take a look out there in YouTube land. Remember to hit that like button. You said it right. Does the presentation also apply to docks in the back property of a single family home? We will get to that, David Englehart. And we just had a task group meeting today where we talked a little bit about that as well. Tucson, Arizona is where the next electrical safety. Thank you, Nihad. It's Tucson, Arizona for the next electrical safety workshop. All right, so let's start this discussion with understanding what a marina is, because we're going to be using that terminology a lot. Marina is defined in 555.2, because you remember, per the NEC style manual, .2 is where you're going to find definitions, and I believe that's consistent with all articles. I know of one example where it's not, which hopefully we'll fix in the future. But a marina is a facility generally on the waterfront that stores and serves. It says generally on the waterfront. It doesn't say always on the waterfront. That stores and serves boats in berths, on moorings, and in dry storage or dry stack storage. Now, I will say what you'll see in the 2020 version, I believe it was the 2020 version, I pulled together a working group, and I sometimes mix the 17 version, but it was the 2020 version. And what we did in our working group, we had guys, I had rock stars like Cliff Norton and Dean Hunter and others who are heavily engaged in this, and Donnie Cook, Shelby County, Alabama. We worked last cycle to basically take a look at 555, because here's what happens. Chapters 1 through 4, they get all the big guns. From a code perspective, everybody's focused on what the words say in chapters 1 through 4 because they apply generally. Once you get past chapter 4, 5, 6, and 7 don't get as much, I call it love. They don't get as much love from an attention to details in the language of the code. So in this cycle, in the 2020 cycle, I pulled together a really good team of individuals, and we made a lot of changes. One of those changes was to align the definitions in Article 555, or actually, there wasn't that many definitions in Article 555. We pulled a lot of the definitions out of NFPA 303, which I have that document. We're going to talk about that as well. And that's why you see this reference there on 303, which is specifically section 3312. So a little lesson for you. Anytime you see, look at this, I got to get my pen out. That's what I do. Anytime you see behind the text in the code a square bracket 303, that tells you it's NFPA document 303. And then 3312 is the exact section that's taken from. And what the rules are is that we call this extracted text. We didn't change anything in 303 in this definition of a marina. So you're going to see a lot of that in the code in general, but especially in 555 on all of the definitions, we took those directly out of 303. And the thought process there is we wanted to drive a consistency. If you're doing marinas and you don't have a copy of 303, you're not doing marinas, okay? You've got to have your references in order. So if you're a marina kind of guy or gal, you're going to have 303. And the terminology used there has to be consistent with the terminology used in 555. Very similar to NFPA 99 for healthcare and 517 and other areas in the documents of NFPA world. So that's a marina. So when you see images like this where you have a docking facility, these are obviously that's a marina. Obviously, this is a marina. Those are floating structures, and we're going to talk about what a floating dock is versus a fixed dock, etc. These types of floating structures that'll have these, buoys or whatever they call them. They float up and down because of the tide. And we have to think about that from an electrical perspective, because if my entire structure that I'm taking a feeder to is floating, I need to accommodate, or moving up and down, I need to be able to accommodate that from a safety perspective. There is some signage requirements that were introduced. I believe it was in the 17 code. They're still there in the 2020 code. And I tell you what, we just had the discussion today on our bodies of water task group. I don't believe that sign is going away, but it doesn't say no fishing or no swimming. It just raises the awareness of the electrical hazard when there's electricity in the water. All right, I am going to move I'm just going to do, I know this is going to be distracting for me, but I'm going to put my, I've got like 3 monitors going at the same time, but I'm putting my comments up there so I can see your live chats. So Marinas received the attention because the problem is real in these installations. And I was showing a video earlier of Lucas Ritz, and Lucas passed away in a marina. His story, I made that some pre-reading for you. I gave the links to his story down below in this, and also on the GFCI side of the business. I put this a while ago. I just randomly put this out there on my Facebook and my LinkedIn site because it's worth watching that video to understand how this whole concept of electric shock drowning came to be. But Lucas, what happened, I'll give you the story. Back in 2010 or 9, I think it was, there was a gentleman that I worked with, Joe Fellow, who I was involved with codes and standards. At that time, I was product manager for ASIs and GFCIs. And he put Lucas's story on my desk, and he said, "You're involved with the NEC. Why can't we fix this problem?" And I told him, I said, we had a discussion about it, and I made a deal with him. I said, "You come up with the substantiation, and I'll try to come up with some language." And we did, and I'll talk about this a little bit more when we get into the ground fault circuit interrupter requirements in marinas. But we made a lot of waves in the marina world together. He and I did, and those waves continue. So, but that all started with Lucas Ritz's story for me and for Joe. What we learned about was Michael Cunningham. Michael Cunningham died in West Virginia. He was an electric shock drowning victim. Stonewall Jackson Lake, which is where our western section is going to be when the West Virginia chapter hosts the western section. So Michael Cunningham, he passed away when he was swimming behind the boat. He reached for the ladder, so to speak, and he was electrocuted. What we're learning is across the country in various states, what happens is we lose a child to electric shock drowning, and then a bill will prop up in that person's name, in that child's name, or so far it's been children. We had the Michael Cunningham Act in West Virginia, and at one point, I know I did a lot of programs around this topic for our West Virginia IEI chapter with the state fire marshals and others who were planning to work in and around marinas and try to upgrade, because the way the law was put into place was that all existing marinas had to be brought up to date at that time. So, and there was a specific, cutoff date when that had to happen by. But what we learned was there weren't too many people who were knowledgeable about what was going on and how to engineer or how to put together these systems and what the code requirements were. So our efforts in West Virginia that I was very closely aligned with Jack Jameson from the West Virginia chapter IEI and others in the West Virginia chapter of the IEI, International Association of Electrical Inspectors, we worked hard to put on some programs, and we actually did a program at Stonewall Jackson Resort where Michael Cunningham passed away. And I do have some pictures of that installation because they were updating it at the time, and that was a perfect time to do an educational program. Other people that were lost. This is Noah Winstead and Nate Linham. And their death in 2012 drove the Winstead and Nate Lanham Electric Shock Drowning Prevention Act, and that was in Tennessee. So you're going to see various bills crop up across the country because this is an issue that we have in and around these areas where we're electrifying equipment and whatnot around a marina. And historically, and you'll notice if you watch that video, and I highly encourage you to watch the video with Lucas's father and his mother and his brother, Lucas Ritz's story. And his father noted, he said, he was told that his son drowned, but his son had a life preserver on. And he said it could not have happened because he had his life preserver on. I was there. He was there. He saw it. He knew what went down. He wanted an answer. And it was his efforts in kept pushing for an answer that drove the awareness of electric shock drowning. He dug up enough examples where deaths were accounted for as electric shock drowning, or they were accounted as a drowning, or some other reason that it wasn't necessarily associated with electricity. So he was really drove that. Michael Knudsen, 18 years old. I'll let you read that. Here's a story, and I hear this a lot too. What happens is you have somebody in the water who's struggling, right? And Lucas's story did the same thing. What did his brother say? His brother said Lucas had a problem. And then what did they do? They all swam to help him. In this case, this was somebody was struggling. The family patriarch jumped in to assist, or it was the dog. And then he started struggling, and then the two sons jumped in. There are cases where you have multiple people dying in one area because they were all trying to help each other. And another message that Lucas's father puts through, and other people in these areas around when something happens, is, when you feel something in the water, the natural tendency is to swim to shore, right? So what do you see? You see that ladder hanging off of the pier where you came in. Something is going on. You're struggling, and what do? You swim to the ladder. And unfortunately, in some cases, that ladder could be what the problem is. This was a 15-year-old girl who died in Lake Tuscaloosa down in Alabama. Carmen jumped off the family's boat dock, and they heard Reagan screaming for help, and then they tell the story about this poor person, this young lady who passed away. They felt shocks. They heard people say, they said to cut the power off. There was, if you just read through this, I mean, it's heartbreaking when you understand that these aren't isolated issues. What Lucas's father found is that this type of thing happens in many locations. They found in this case that it was a light switch at the dock that was half full of water that was causing the electric shock, the electric currents to flow in the water. Very heartbreaking, very disturbing, and it's a problem that needs a solution. And I'll tell you right now, we talk about electric shock drowning. We talk about different tools. I know there are some products out there that have come onto the market that are trying to raise awareness when there's stray currents in the water. But in reality, there's no listed products available on the market today. So, from a listing requirement perspective, the availability of solutions that are listed to a standard, because there's no standard that for technologies that you can put in the water that'll let you know when there is stray current flowing in the water. So when you think about what is electric shock drowning, you've got to think when you have a fault. I mean, we all understand, and Nihat and I talked about this on Monday. We talked about step potential, hand to foot touch potential, right? When you have current flowing through a body, whether it be water or the ground, the distance between 2 points adds an impedance, and we all know that, you know, when you have an impedance, current flow through an impedance, you have voltage potential from one point to another. That's why they tell us if you are afraid of you know, like a lightning strike or some stray currents in the ground, or you keep your legs close together, hop away from the source of the electricity, things like that, because you don't want a potential. And if you think about a water and a swimmer, the swimmer is typically elongated in the water, you know, unless like me, I bob, right? You know, and you do some of this stuff. But in any case, you know, you are creating the potential from your tip of your nose, from your head or your hands to your feet as you're swimming through. And then as you enter a field, you can have current pass through you. Now, it's important to understand, and I've heard people say, well, you have that problem in freshwater, but you don't have the problem in saltwater. The reason freshwater, they'll tell you that they'll say freshwater is close to 70 times more resistive than saltwater. And when I first started going down this road years ago to try to understand that, you've got to think about the impurities inside of water, like salt water, for example. You've got salt, saline solution, very low impedance. Why? Because there's a lot of material, there's a lot of things inside the water that help lower the resistance, the impedance for current to flow through that water. Fresh water, in fact, what do they call that? You know, when you boil water or whatever, the fresher, the cleaner, the less impurities inside of water, the higher the resistance. So what happens is the human body becomes a lower impedance in relationship to the impedance around them in the water. So because you're a lower impedance in parallel with a higher impedance, the current's going to naturally want to flow through the body as opposed to the natural, that water in a fresh water. Now, there was an IEEE paper, I think it was last year, that focused on electric shock drowning, and it looked at salt water. Now, they made, the authors of that paper were trying to say that salt water is just as, or more of a hazard from an electric shock drowning perspective because of those impurities. Now, some people will say you don't have this problem of electric shock drowning in salt water because the salt water is a lower impedance and less current will flow through the human body. I go back to, where's the body count? The body count is in fresh water. I don't have body counts in salt water. And I ask the question, you know, in my mind, I think, why is that the case? Especially when there was an IEEE paper done that said salt water is actually worse. And their argument was that if you think about the zone, that radius of, so if you think about what's going on, if I have an electric source in water at this point, I will get rings of gradients where my current is flowing from that back to the source, right? So the where I have a fault, so if I have, for example, if I have a pier and I have a boat parked here and there's a fault at this point in the water, I will have those gradients, rings of circles of magnetic forces or the current that's flowing, trying to get back to the source. And as a swimmer swims into that, they're swimming into that range. what this IEEE paper, the author was implying, is that because salt water is so less of an impedance to current, that you actually get a larger range of current flow further from the source than you do in fresh water. So if I have a very high impedance, maybe in fresh water, I eliminate most of those rings. But his argument was, then he's done some measurements, that those rings of current flow are further out in the water. But again, my perspective is that, when I look at the conductivity and resistance of water, I understand that fresh water is less pure. I understand that there's more resistive, and I am a lower impedance. I would never say you can't get shocked in salt water. I would say that when you look at the resistivity of the differences between distilled water, that's the term I was looking for before. The conductivity in distilled water is 0.5 to 3, very low conductivity. So it's very hard to push that current through distilled water. Fresh water is 100 to 2,000. Potable water is 30 to 1,500. Melted snow is 2 to 42. Seawater can be upwards of 55,000 microohms per centimeter squared or per centimeter. So, the seawater has a very high conductivity. Sorry about that. So, in any case, I'm going to take that out so I don't get that mixed up with you guys. So, in any case, when I think about, that fields that are flowing in water, the closer you get to the source, the higher the amount of current. And if you watched the Lucas Ritz story, his brother said that he felt the water pulsing. Water doesn't pulse. What he was feeling was his muscles pulsing, right? Because of the contractions. That played a key role in his experience with regard to when he was swimming into that stream. So the closer you get to the source, as you swim in, you're going to be elongated, right? So you're swimming. What Lucas's father does a training program, and what he tells people is when they're experiencing that, to get into a ball, right? It's no different than, if you know, for example, there's a down power line. Say you hit it with a vehicle and you jump out of the vehicle, there's instructional videos that say, you hop, you keep your legs close, don't walk, where you're putting one foot in front of the other. You hop away from the source because you don't want to create that potential. Same thing goes for the water. Pull yourself in, try to keep your, almost assume the fetal position, grab your knees type of deal, make the distance between any 2 points in your body as close as possible, because you're in an electric field, and you are, if you're in fresh water, the lower impedance, so more current's going to be flowing through you. For some reason, I'm not saying, I don't know if you guys if anybody's commenting or not, but I'm just going to check. There we go. So, all right. So I wasn't seeing. So the required signage in 525X to increase the liability of the owner. All right. Tucson is where the next. Okay. So, all right. I'm going to move on. So now, what we know, again, from our discussion on Monday, that 1 to 8, we have that tingle sensation. And if you listen to Lucas's story, his brother talked about the tingling sensation as he was swimming. Then he talked about the pulsing sensation. And my contention is that's probably very much in line with this. Now, nobody was measuring the current that was flowing, but we do have an indication of what that current was, probably was, that he was experiencing. And this is when, they said they felt a slight tingly sensation in the water and immediately backed off. Then the other part of that story was his mother jumped into the water to save him. And what did she say? She couldn't move. She originally thought it was the adrenaline. It was something else other than current. And then Lucas's father is the one who pulled them all out of the water. That is, when our body experiences this in the water, we don't have the potential to swim, so we sink, and that's what will typically cause some drowning. And then by the time they find you, you're outside of that. They may not have even known where you experienced that electric shock. These are the types of issues that you'll see. The marina is a very harsh environment. We can't expect these solutions to last forever in these marinas. Maintenance is going to be higher. We need to recognize that tie wraps, the MacGyver fix, is not the solution. This is sort of an overview, and we have to understand where currents are going to flow. And what we did in the Article 555 was we basically went through and we helped define all these different parts and pieces. We took those from NFPA 303, that was the 2016 version at the time. We defined what a pier is, what a covered pier, a fixed pier, a floating pier is. We kept those definitions in alignment with 303 so that we all understand what we're talking about when we're dealing with these locations, what a slip was, what a mooring was. I'm not a boater. I didn't know what a slip was. I didn't know what a moor was. I mean, I know what moor is. I want more when I sit down to eat, but I didn't know what a moor was when it comes to a boat or a marina. And these terms in some cases are used in the code. In some cases, they're only used in other definitions. So we still put them in, even though there wasn't a use of the word in a requirement. If the term was used in another definition, we still put the definition of that term in there because it helps you understand from a transparency and completeness of the information. Now we have power distribution on the piers. That power distribution can be in the form of transformers, panel boards, switchboards, and all that jazz. Every one of these boats is going to get power, and this is what happens. You'll get areas where the conductors that maybe even be in the water next to the pier where the boats are pulling in, and you will get the scraping of those conductors, exposing the energized parts, and those are in the water, and that can be where it comes from. If you could have faulty wire on a boat, like in this case here, this was on a boat. This was faulty wire that you may say, I have a fiberglass boat. I'm insulated from the water. You have a prop, a metal prop on your engine that is in that water. Unless everything on your boat's plastic or everything is rubber, you're not insulated or isolated from the water from an electrical perspective. The moment you put a ladder down into the water, that can cause a problem. So, when you look at some of these examples and you're looking at exposed conductors that are energized, that's where this stuff comes. We went and I had the fortunate ability to accompany an electrical inspector, Donnie Cook, and we looked at multiple. Donnie, I went with Donnie. I also went with Jack Jameson to a marinas, and we looked at different marinas, and you would be surprised at what you will see just walking on the docks. Duct tape, very prevalently used in marinas. And I can laugh at some of these, but it's sad when you know that there's body counts associated with the faulty wiring and the MacGyver's nature that we have in getting things done in and around marinas. Saw a lot of this, and you remember one of those deaths was due to water inside of a receptacle. Now, this is supposed to have a cover plate on it, and then this is just the metal structure, but I've seen some, don't misconstrue that as being an electrical enclosure. That's just the pipe or the fixture holding that up. But when you look at things like this, and this is me, and that's that's Donnie. But, when you look at some of these boats, they're doing a lot on these boats. This guy had a refrigerator. They had a freezer. I was so tempted to see what was in that refrigerator. But in any case, I didn't. Then you look at products that are being used. This is not listed to be used outdoors, yet they took that power strip and they tie wrapped it onto that metal bar, and that's what they are using. And in some cases, they'll take the dead fronts, they'll take these cover plates off, and they will wire in to get done what they need to get done. People won't do plumbing at the house, but they don't have a problem doing electrical work. So that's just a thing that we live with in our industry, I guess. People will make those modifications. So So the bottom line is that it's not just the wires on the shore, on the pier, that will drive shock and areas of having issues in and around these things. It could be the boat themselves. The Lucas Ritz, it was a problem on the boat. It wasn't a problem on the shore. There are many examples of grabbing a ladder or other issues with the infrastructure wire, but there are just as many, if not more, of examples of problems on the boat that caused a shock in the water. So you need two things for an electric shock drowning. You need a fault to ground. You need an exposed conductor or some exposed wire in the water that is leaking current into the water. And then again, that current's going to flow through the water and then back, trying to find it back to the source. And unfortunately, it can go through whoever's swimming in that area. NFPA 303, I mentioned that a couple times. That is the fire protection standard for marinas and boatyards. And again, obviously you have NFPA 70, which is the National Electrical Code, Article 555. Then you have the ABYC, is the American Boat and Yacht Council. And the reason I put that there was because a boat, the ABYC creates standards that help you establish how to build boats and what the requirements are for boats. Now, it's not like a UL standard where there's a code or something that says you have to build it to that standard. The ABYC creates guides on constructing boats, and I'll call it a guide because it's not a code, it's not a standard, it is an elective thing. And the reason somebody would list their boat, so to speak, or get it evaluated, I like that word better, to the ABYC standards, is because they want to add marketing value to that vessel to make it the better choice or make it the safer solution, so to speak. So maybe somebody will buy that vessel over another. There may be some requirements out there that say, you must have that type of a boat listed to that to be able to put the boat on that water. I don't know those details, but I just know that the ABYC documents that are referenced for boats that drive 30 milliamp ground fault protection on the main inside the boat, which was an influence in the code, 30 milliamps, GFPE protection. That comes out of the ABYC, but you're not required to build your boat to that standard. Now, 555 focuses on marina. The way it's separated, you have general requirements, you have marinas, boatyards, and docking facilities, and then you have floating buildings. It's part 3. And what we did in the 2020 version, we took out of the 17 version. This is pretty bad when you're reaching on the floor to grab all your things. There was a 550 or a 550. I think it was 554, if I'm not mistaken. 553. 553 was floating buildings. And what we did in our task group, in our working group, we sat down and said, you know what? When you look at, there was an issue with the scope. 553 scope said, this article covers wiring, services, feeders, and grounding for floating buildings. Pretty straightforward, right? when you looked at the scope of 555 for marinas and boatyards, the scope statement said, this article covers the installation of wiring and equipment in the areas comprising fixed or floating piers, wharves, docks, and other areas, marinas, boatyards, boat basins, boathouses, yacht clubs, boat condominiums, docking facilities, right? And floating buildings is in that list. Where is it at? Decking facilities, residential condominiums, multiple docking facility or similar occupancies, the facilities for the purpose of repair, blah, blah, blah. So we had a conflict where we had floating buildings in the scope of 555, and also we had a whole article focused on 553. So we said we had to do something about that. Right now, in the 17 cycle, they added 1 and 2 family dwelling units, which David Engelhardt asked, does this presentation also apply to docks in the back property of single family home? And because 555 was expanded in 2017 to include 1 family dwellings, 2 family dwellings, and multifamily dwellings, the answer to that question, David, is yes, it does apply to those applications because of what happened in the 17 code. And we just had that discussion in our meeting today, our task group meeting. We're looking at 682. Remember, 682 focuses on man-made bodies of water, and I hope I got that article right. I should, because we talked about it a lot today. 682 is natural and artificially made bodies of water. And our discussion, one of the comments that was made, that the moment you say you have a lake behind your house, a little pond, the moment you put a docking facility and a dock, you are now into an Article 555. If you don't have a docking facility where you park your boat, you fish from shore, you're not in 555, you're in 682. But the moment, now you could have a boat on shore and say, I'm going to use that boat because you might have a pump out in the middle that handles overflow or whatever it does for you. You may have electricity in there, and you might say, you know what, every now and then I got to get out to the center to check on that pump that might be out there. In that case, I would point you to 682.3, which says if the water is subject to boat traffic, the wiring shall comply with 555.13b. And we had this discussion just today that we're actually going to probably change that to say reference part 1 and 2 of Article 555, because it's more than just 555.13. But if you have a boat, you don't have a docking facility, you just have a boat sitting there that you're going to be using, so that's boat traffic, to go work on something in that pond, that man-made body of water of yours, you're now being pointed back to 555.13. And 555.13 talks about wiring methods and installations. So there are certain things you're going to have to do the moment you involve a boat. The moment you put a dock in that area, you are in 555 as of the 17 code, and that carries on in the 2020. Yeah, a beautiful fountain in the middle of the lake would apply to 682. That is exactly right, David. So 555 is separated into general, into marinas, boatyards, and docking facilities, and then whatever was in parts 1 and 2 or whatever was in a floating building, that previous 553 article, whatever was in that could not fit into the other areas, that was really specific to a floating building, we put in part 3. So we consolidated that, and I think that was a good thing. Now, we can't forget chapters 1 through 4 apply generally. So, 210.8 will apply, and all of those other requirements in chapters, 2 and 3 will all apply. We can't forget about chapters 1 through 4. And Bruce pointed out aerators in a sewage treatment pond. Yes, That is right. That's a 682 facility. And I don't know anybody who would put a docking facility in a sewage treatment pond. I'm just saying if you do, you're in 555. I don't know that I would do that. Now, because 1 through 4 apply generally, and Article 90 is the, and I got a picture of somebody dumpster diving because why? Article 90 is the instruction book, right? That's the instruction leaflet for the National Electrical Code. And what do we do with that? We throw that away. And I would say there are a lot of people out there that have probably not really read there are a lot of inspectors that definitely read Article 90, but there are probably a lot of engineers and contractors and others who have not spent any time in Article 90, and I would suggest that you do so because there's a lot of good stuff in Article 90. 90.2 tells you what is covered and what is not covered. You have covered, not covered, and then special permission. In the 90.2a, what is covered, we had a change in the 2020 cycle focused on, where's my pen? See, I love the fact that I can write on my monitor. Right here, it says installations supplying shore power to ships and watercraft in marinas and boatyards, including monitoring of leakage current. And you'll say, why would you have that in 90.2? What is this? Including monitoring of leakage current. And I'll tell you, there was a change in 555.35. Leakage current, if you go back to 555, and I know everybody's got their code book, and you're looking at it, 555.35, we made a lot of changes between the 11 cycle, the 17, and now into the 2020 code. And there was actually a TIA on 555.35, which deals with the ground fault protection of equipment and ground fault circuit interrupter protection for personnel. You'll notice a new B. In B, it says leakage current measurement device. And what it says is where more than 3 receptacles supplying shore power to boats, a leakage current measurement device shall be available and be used to determine leakage current from each boat that will utilize shore power. I'll tell you why we did that. The reason we did that was because of the requirements in 555.35 around ground fault protection of equipment to all of the feeders and branch circuits. And if you recall, in the 17 cycle, I'm going to go over 555.35. So I'm not going to get into the 17. I'm going to give you that backstory and help you understand the journey. I'm not allowed to say journey anymore. There is a friend of mine who says that he doesn't like when I say journey. So the journey of electrical safety in marinas around ground fault circuit interrupters and ground fault protection of equipment. So they put this requirement in so that you can basically bring a boat in, and there was basically somebody there was a member who does this, actually implements this in their designs. This leakage current measurement device gives the ability for that boat, when it first enters into that marina, they can monitor the boat before they let it power up, before they let it plug in, because the fear is if I have ground fault protection on the feeder feeding the entire marina, or ground fault protection feeding the entire pier or docking facility, I don't want to take it all down because one guy elected to do his own wiring on his boat and is pulling a lot more amps than whatever that trip level is of the ground fault protection. So they wanted a provision in here to encourage people to say, look, when you have more than, how many boats? When you have more than 3 receptacles supplying shore power, so that's probably 3 boats, more than 3 boats supplying, that means that you are going to be putting in a temporary measuring device, a leakage current measuring device that they can plug the boat into before they plug and take down the marina. Because we know what happens when you have an unwanted tripping issue. and especially if it keeps happening, we don't stop and say, what's wrong with my circuit? No. We say that daggone device keeps tripping and I need to keep my power going. I'm going to bypass that device and I'm going to make it happen. So we don't want that to happen. We want people to have the ability to say, let's test your boat before you plug in. And the way I've talked to one Marina owner, the way he does it, he requires people to check in. They plug that boat in. If it is more than, say, 15 or 20 milliamps, whatever that number is that they decide to be the cutoff, they send them to a dry dock, a place where there's no power to the dock, and they tell them, you're going to dock your boat over there until you figure out what's going on your boat. That way they don't take down their marina. So they added an informational note to help us understand that. And they also said an annual test. Informational notes are not requirements. There's not mandated requirements there, but they're encouraging people to do an annual test of the boats to see if there's any hazardous current. And quite frankly, what we're learning is that some of the boat owners do they don't mind wanting to find out if their wiring on their boat has issues. I mean, I think that most of us want to do the right thing. And I believe firmly, and based upon demonstration in the field, I think everybody would be encouraged, wouldn't mind plugging their boat in to see what their leakage current is. So that's what happened. But in 555.35, there were a lot of changes over the last couple cycles. Actually, I believe it was the 11 cycle. I have the language in here that started this whole focus on ground fault protection. But the focus is, we've got this shore power receptacle that's supplying boats. We have this receptacle that's not meant for shore power that is there for, powering tools on the dock, etc. That 30 amp, or in this case, it's a 50, no, that's a 30 amp receptacle is to provide power out to the boat. So, and shore power is now defined in the code. So in any case, that shore power this now has to have protection where before it did not. You'll notice these are standard thermomagnetic breakers in here, and the only way to protect a 50 amp or a 30 amp receptacle outlet is going to be through a GFCI circuit breaker. And that will be in the pedestal. And this pedestal is required because you need to have a disconnect for that boat. For whatever you're supplying shore power to, there's a requirement in 555 to provide a disconnect, and it has to be within so many inches of that receptacle. And the best way to get that done is through a Marina power outlet. And we'll walk through that as well as we move forward. Now, it was in the 11 public inputs where Joe Fellow, it was probably 2010, because or maybe it was 2011. That's when Joe put that on my desk, and we came up and we said the main overcurrent protective device, which feeds the building or floating structure distribution system, shall have GFCI protection. So we went straight to GFCI. I knew it didn't have a snowball's chance, and where, but I was interested to see what the panel would say, and what they said was really interesting. They said, although the recommendation has merit, and I'm like, that is a good sign because they recognize there is a hazard, but they also recognized that the proposed requirement for personnel protection is not practical for all floating building environments because of the leakage currents involved. So what Joe and I did, we went and Joe Fellow worked for Eaton. He's retired now. And what his job was to test. He was our UL guy, and he was in our residential product line, and he focused on testing all of the GFCI circuit breakers. So he knew GFCIs and the UL standards associated with that. We tested and we grabbed every one of our manufacturers' products, and we found that from a ground fault protection of equipment perspective, if you understand UL 1053, and if you don't, we talked about this in our presentation on Monday with Nihad El-Sharif, that GFPE, the pickup point, is established by the manufacturer, or it's established by the engineer or whoever it is that's setting the device in the field. So a UL 1053 device doesn't have a designated pickup value. The manufacturer does that. We, from an Eaton perspective, we use 30 milliamps for ground fault protection of equipment on these smaller circuits. Other manufacturers use different numbers, like 50 milliamps or 60 milliamps. Nobody used anything greater than 100. So what Joseph and I did was we said, well, we're going to go back. They didn't like 6 milliamps. Let's put 100 milliamps, because quite frankly, if you have more than 100 milliamps flowing in your circuit, you've got a problem. Remember, this doesn't limit the current to 100 milliamps, that any current greater than 100 milliamps will trip this device. Actually, it's probably a little bit more, because the way the 1053 device standard is written, it won't trip at 100 milliamp. I think it's 115% it has to ultimately trip, and then 120 some percent or whatever it has to trip within so many seconds. So in any case, there's defined clearing times in that regard. So, so this was our second chance, and look, it passed unanimously. So that required 100 milliamps at the service, and what we did was we said ground fault protection of each individual branch or feeder shall be permitted as a suitable alternative. So our thought process was you can either put it on the main, or every feeder put 100 milliamps. Well, that generated, or anything 100 milliamps or less. So the first issue that came up was said, well, nobody makes a 100 milliamp device, but it says not exceeding 100 milliamps. So that's sort of where we were. And remember, this is not, our intent was not to prevent the heart from going into defib, because I see Bruce was there. Probably, Bruce was, hopefully, Bruce, you learned the 50 milliamp number on our call on Monday, but 50 milliamps is that ballpark number where your heart may go into defibrillation. And remember, the European standards settled at 30 because they're worried about the heart going into defib. In the United States, we worry about the let-go threshold, so we lowered that down to 4 to 6 milliamps. What this 100 milliamps is there to do is not protect a person once they've come in contact with an energized part. This 100 milliamps in our mind was to recognize a problem exists and take it offline before the problem would For example, either the Lucas Ritz or some of these examples, I could say the moment that there was definitely a lot more than 100 milliamps flowing in that Marina, and if GFPE at 100 milliamps was present, then it would have found that problem probably before somebody touched anything. And so it looks like Bruce was involved with a forensic case 30 years ago. You got a good memory, Bruce. So that's where he got that 50 milliamps. So, and that number is not new. That Nihad and I, that research was done a long time ago. And in fact, Nihad and I have talked a lot about some of the research that was done back in the 30s. So this information has been out there. So the way 550, when 2011, that is what we said that would pass. And what happened was people didn't like that. So they went out and drove a lot of activity. People were really upset that we had this requirement of ground fault. They said there is no way that a Marina would be able to exist and function with 100 milliamps on its main. And then I, arguments and debates ensue after that fact. So I would, at this point, I just raise the awareness that there is the Research Foundation. So you can go to the NFPA Research Foundation. All I did was Google NFPA Research Foundation, and you'll find this page here, and you'll find that there's a lot of really good information out here where you'll see resources, Research Foundation, about the foundation. You'll have library and archives, and you can look at the library of I wanted to go research reports right down here. So this is all of your research reports, and you can, and again, the Research Foundation for NFPA doesn't just focus on electrical, although we matter most. But in any case, The electrical, you can click on electrical and you'll find a lot of their reports. So this was the home electrical fires, and they're showing that the downward trend of electrical fires due to all the great things that we're doing in the in detecting arcing and sparking in residential homes and otherwise through AFCI technology and more. You have the electrical fires, incident and injuries. There it is, electric shock drowning. So there's a Marina risk reduction study that was initiated. There's the assessment of hazards. That was the 2014 document that that I'm showing in this thing right here. So that document there is accessible to you for free for download. And there's a lot of other cool documents out here that you should be aware of if you're interested in electrical safety. So you can get that document, and then the more recent one, which drove changes in the 2020 cycle that basically changed it and moved it from, which was really cool, because what happened was we threw out this 4 to 6 milliamp. They argued, pushed back. We threw out the 100 milliamp, and they still said, you know what, we need research around this because we don't agree with that 100 milliamp. We don't like that number. And then what they did was they went back to this newer Marina risk reduction document, and basically the code changed and said all overcurrent devices had to have 30 milliamp ground fault protection of equipment. So it went down instead of up. But what I think you will be pleased with what we did in 555 with regard to a tiered approach. So that this is what was the change in the 17. Based upon that study, they went to 30 milliamps on all overcurrent devices, which proved problematic because 30 milliamps at the main was still a little bit too low of a number. So we went back to 100 milliamps in the 2020 cycle. So this is a picture, an example of what a device that's in a marina that actually has ground fault protection, and there's a label that shows you that. So here's the language that was settled on in the 2020 version, and they moved it from .3 to .35 because we completely rearranged Article 555 in the 2020 cycle. Now, what we said in here was, we said for other than floating buildings, ground fault protection for docking facilities shall be provided in accordance with A1 through A3, and the receptacles providing shore power. So any receptacle providing shore power, and you have to understand what does that mean? So shore power is I'm going to read the definition for you out of the code book. It says the electrical equipment required to power a floating vessel, including but not limited to the receptacle and cords. So we know that when we use the term shore power in 555, it is anything that's powering a vessel. Now, what drove the 30 milliamps was the fact that the ABYC, American Boat and Yacht Club, I got it right. I always do the C before Y, except Y after C. So the ABYC includes requirements for 30 milliamps on the boat itself on the main. So that 30 milliamps aligns with the ABYC, and they'll have a 30 milliamp leakage device in the boat on the main in that boat. So they have 30 milliamps on the dock, 30 milliamps on the boat. We're golden. And if your boat doesn't have the 30 milliamps because you elected not to follow the ABYC, when you plug in, you're going to find out if you have more than 30 milliamps, right? I'm just looking at Lisa Koyan. Thanks for joining us. If you are going to a resort that has a dock, what questions would you ask them before staying there? I don't know. I wouldn't limit my stay. I would not swim in and around that marina. If they have a boat dock there, do not swim in and around it. And I wouldn't, I probably, unless you're out in that arena, if you're going to do some fishing off the dock, just be mindful of your surroundings. Don't touch things. If you don't know when it was built, and how you can tell. I have pictures. I've got pictures of boat docks for you to show you. You'll be able to recognize when there's some hazards there. But you definitely do not want to swim in and around that marina, boat docks. Just be mindful of that. But you can still stay there. GFCI protection for personnel. All 125-volt single-phase 15 and 20 amp receptacles shall be protected in accordance with 555.31 B1 and B2. So let's take a look at B1 and B2. Well, wait a second. 555.33 B1 and B2. So I'm going to read that to you because I'm not going to go bouncing back and forth. 33 B1 and B2. That says GFCI protection for personnel, receptacles in other locations shall be protected in accordance with 210.8. So that was another part of the effort in the 2020 cycle, moving things and pointing things back to 210.8 because we want to make sure that we align ourselves with 210.8 and those requirements for those outside circuits and etc. Right? And then B1, B2 says receptacles other than those supplying shore power, because remember, shore power is going to be at 30 milliamps. And it says, other than those supplying shore power to boats shall be permitted to be enclosed in marina power outlets with receptacles that provide shore power to boats, provided the receptacles are marked to clearly indicate that the receptacles are not to be used for shore power. And we did see a picture of that. I'm going to throw that up there real quick for you. There's an example. So I almost wrote on that screen. So there's your shore power, and this is the one that's not to be used for shore power. All right, so that's it has to be indicated, and it is GFCI protected. And now, per the new version of the code, this will have to be GFPE protected at 30 milliamps. This will have to be GFPE protected at 30 milliamps. And I'll tell you how they get it done. They're going to get it done by putting GFPE in the breakers that supply power to those receptacles. All right, so I got to get back to where I was, and I don't know if I remember where I was here. All right, so that's and in accordance with B1 and B2. So I just read both of those. B1 says receptacles in other locations, you need to follow 210.8, and anything that's other than shore power can be put on that per pedestal, but it has to be marked not for use for shore power. So you can't power a boat. I don't know that you would power a boat off a 20 amp circuit. But that is for a different day. So now, A talks about ground fault protection. For other than floating buildings, ground fault protection for docking facilities shall be provided in accordance with A1 through A3. We already said that. So now we're on 3. So we did 1, we did 2. Remember, 1 was the branch circuit. 1 was actually the shore power, right? That was the 30 milliamps. A1 was 30 milliamps. That was your shore power. A2 was your receptacles, 15 and 20 amp receptacles, and anything in accordance with 210.8. And then 3 talks about your feeders. So a feeder, now we're moving up in the power distribution system. We're moving from that branch circuit receptacle that's feeding the boat, or receiving or the branch circuit receptacle that's feeding your power supply for your tools and whatnot. Now we're into the feeder. And the feeder has to be protected at 100 milliamps. So 100 milliamps, now, I know that there was a debate. People didn't like 30 milliamps. We actually had a couple people that said that there are marinas working at 30 milliamps. And I'm not going to argue against that because they are. And that was in Kentucky. There was one person who was on the panel that is a marina builder, and he said that 30 milliamps, just because of standard, earth leakage due to multiple locations. We saw various types of appliances that may or may not have limitations. It depends on how many boats and how big of the marina it is. But that person said, I'll be happy with 100 milliamps instead of 30. So 100 milliamps was something that you can get 2/3, and now you have a tiered. If you think about it, you have a tiered ground fault protection. You have 100 milliamps at the feeders or the service. You have 30 milliamps going to the boat, and you have 4 to 6 milliamps on all of the other receptacles. So you have a layered approach to ground fault protection in these environments, which I think, in my opinion, is a great step in the right direction. So we had 100 milliamps, and it says, coordination with downstream ground fault protection shall be permitted at the feeder overcurrent protective device. Why? What do they mean by that? Well, let's talk about, like, if you had a overcurrent protective device, a standard, not a thermomagnetic breaker, say a circuit breaker with an electronic trip unit. That's sort of what the trip curve would look like. We call that the time current characteristic curve, where we have current across the bottom and time up the side, right? So that's time and this is current. For increases amounts of current, we have a decreased amount of clearing time. This tells you how long it will take that breaker to trip based upon various values of current. Ground fault currents, if this is say it's a 200 amp feeder, your ground fault currents are going to be in the milliamps. You're never going to trip a circuit breaker upstream. The ground fault curves, I call them, they look like a hockey stick. All right. Sometimes you'll have an I squared T in there, it'll do that, but let's just for this discussion say we have a hockey stick. When we say in that text that it can be coordinated, that means that I can actually add some delay, intentional delay, to permit the downstream ground fault protection devices to trip first. So this may be my GFPE down at the receptacle in that standard thermomagnetic circuit breaker. That's the residential type M molded case circuit breaker, the small miniature stuff. This could be a good healthy F-frame circuit breaker, a larger breaker that has an electronic trip unit in it, or it could be a thermomagnetic breaker with an electronic trip unit that, or a separate device that has this. So I may elect not to have the ground fault protection inside my breaker. I could have a standard thermomagnetic 200 amp breaker, and that ground fault protection of equipment is done in a relay that shunt trips that breaker and tells it when to trip. It will have a curve, and I can add some intentional delays to get a level of coordination so that if one boat plugs in and he draws 5 amps, if I don't have coordination, I'll trip all of my ground fault protection of equipment upstream. If I have this coordination, then I could have it so that my 30 milliamp molded case breaker in the pedestal takes only that boat out, while the main or the feeder protection has a slight delay. So that's sort of what we did in the ground fault protection. And quite frankly, we're having these discussions and debates right now in other areas of the code where ground fault is required, where they say, well, we don't want to put ground fault in there because we have leakage currents. Ground fault protection of equipment is a great way to recognize a wiring problem or a hazard, an issue in the electrical system, and take it offline before someone comes in contact with it. Ground fault protection of equipment at 30 milliamps, at 100 milliamps, at any of those levels is not listed to UL 1053, is not going to keep the heart from going into defib. That's the job of a GFCI. GFPE can take the problem off before it happens. And then there's that leakage current measurement device that we already talked about. So you have the entire picture. You know why it started, which was, Lucas Ritz really started this because it wasn't until Joe Fellows said, Tom, you got to do something about it. And then we put the public input in the 2011 cycle. Research Foundation, I gave you the resource there, and I'll put a link in this description after we're done in the below this YouTube channel. I'll put that link on the channel. So you've got the entire story. You know the journey. You know where we're at right now. 100 milliamps on the feeders, 30 milliamps going to the boats, 4 to 6 milliamp GFCI on anything else. And don't forget about 210.8B for other than dwelling units, or 210.8A for dwelling units if your boat dock happens to be in the backyard of a residential home. So I'm going to throw some other pictures in here. Now, this photo came from Hilton Head, where the code making panels meet for the first draft meetings every 3 years. Cliff Norton, who is on panel 7, Cliff and Donnie Cook and crew said, they arranged it so that we could go visit this marina. And this device here, a ground fault monitor, these lights provide an indication. If I'm not mistaken, I believe there's an audible alarm. I'm not going to be, I don't want you to hold me to that one. I believe there is an audible alarm, though. I'd have to talk to Cliff to find out if that's 100% accurate. But that gives you an indication of which pedestal has ground fault leakage current exceeding, I believe this is 30 milliamps. There's a lookup table. So you have pedestal 15, all of the different pedestals. So they had a nice pedestal. They have CTs on all of those circuits that go out to those pedestals, and that's how they were able to monitor it. And they are using the Bender relay. I don't know if any of my Bender friends are online. I know the Bender boys were online on Monday, Bender relays. We use those devices from an Eaton perspective. I know we make ground fault protection of equipment as well, but some of our Bender guys we use those below. I'm reading Bruce's note. We use those as well. So mix overflows, it gets the monitor. Okay, so and what they did in here as well, which I thought this was a public input, and I believe our group came up with this idea, our working group. We put a public input that failed, but we said there should be an emergency stop button on each of the piers. And you know what? Quite frankly, I still believe in this. I believe that if there should be an emergency stop on each of those piers that anybody can press. If there's an emergency going on of the electrical nature to kill power in that marina, or at least maybe to that pier where that button is pressed. We saw some good arguments. In fact, there were one of the cases. Remember, early on in this discussion, we talked about this. Remember, my wife thought Carmen had done something to her neck, which paralyzed her. She started going underwater. Johnson and his son Jack jumped in the water after the girls immediately felt piercing electrical shocks, and they yelled, "Cut off the power." And they couldn't get that done. And so our task group used this as one of the substantiations for putting that emergency stop button on the pier, because if that button was readily available there, they probably could have stopped that. Bruce, I agree. An e-stop is a good idea if there's no playful-minded idiots running around. But there's ways to put some guards around that. And this is a very big marina I think I have some pictures of this installation. So we're not talking something that is a small little tiny marina in this case. And this is in, I'm sorry, it's in Hilton Head, North Carolina. And there were a lot of kids, and this was an open area. So this wasn't an area that you would say you shouldn't be mindful of that. This is another example of, this is some of the equipment that was there. They've got their surge devices there. This was an example of the Marina, the power outlet pedestal that they were using. And it had GFCI protection. This was another product that they showed. Cliff pointed this out. This is a product that I don't believe is listed, that's used heavily. Well, they'll split power out of a Marina power outlet for two boats, or maybe there's two 30 amp circuits that we need to put onto that boat, that splitter. So in any case, this is some of the equipment where you'll find your ground fault protection of equipment. And we have to be mindful that leakage currents, and that's what drove the discussion and debate at panel 7, is that you have these different, each boat can be doing 4 milliamps leakage, 5 milliamps leakage, 6 milliamp leakage, for whatever reason. It could be that the appliances that they're using on board have leakage currents. It could be that they have some faulty wiring. I don't know. But that all adds up, and it could take out the entire marina instead of just that boat. All right, I'm watching the chat. There's a bunch of stuff going on over there. I'm just going to read through that just to make sure I have everybody covered. 30 milliamps is easy. Doable. Controls. Wow. The controls send a positive current to the coils followed by a negative current. The waveform at each coil might be a square wave. So this is, does anyone know brushless DC motors, trolling motors is a potential problem? Wow, that's a good question. Well, okay, so usually 12 volts, 24 volts, 36 volts. So John, remember 50 volts is the limit. If we go to 70E, 70E, when you look at talking about work involving electrical hazards, we've got to recognize what is a shock hazard, and there's a shock risk assessment that has to be done. Excuse me. And I believe in here, in a section within 70E, somebody out there in YouTube land might be able to bring it up, but 50 amps, 50 volts. So here it is. Equipment operating at less than 50 volts. This is in 70E 130.1, which is general requirements. .2, which is electrically safe working conditions. A, energized work. And 3 says equipment operating at less than 50 volts. Energized electrical conductors and circuit parts that operate at less than 50 volts shall not be required to be de-energized where the capacity of the source and any overcurrent protection between the energy source and the worker are considered, and it is determined that there will be no increased exposure to electrical burns or no exposure to electrical arcs. So from a shock perspective, 50 volts is your level, and that's DC and AC because it's just a generic statement. So you're mentioning, John, 12 volts, 24 volts, and 36 volts. All of that's below the threshold, so I would say you don't have to worry about those lower voltages. The controls send a positive current. Okay, if you're talking 120 volts, different story. What the voltage waveforms and leakage currents would be, I don't know about that. Bruce noted 50 and 50 milliamps, occurs anywhere between 50 and 100 milliamps. If going to a resort, we already talked about that. 30 milliamps is easily doable if things are dry. Dampness on the boat, yeah, but if it will trip a 30 milliamp trip, it will kill a person. So 30 milliamps could definitely put you, could hang you up, that's for sure. But there's safety in numbers. So Bruce makes a good point, and my thought process is, awareness is important. And as we become aware of this, if you see someone swimming, educate them, educate their parents, make sure they understand the shock hazards that exist in and around those marinas. Let somebody at that marina know about the shock hazards. It becomes a liability issue for the marina as well. Next step forward is to replace GFPE by special purpose GFCIs. 20 milliamp trip current. The advantage of special purpose GFCIs utilize the UL curve designed for personnel protection. So Nihad's talking about the SPC GFCIs at 20 milliamps and what that may bring to the table possibly in the future. 30 milliamps go on a boat. So I'm just looking at some of the comments. It could be done like a glass break. So yeah, that's true. You can have like you have your fire alarm stations. All right. I tried to get a shunt trip stop button to be used in place of locating the service as required in 555.4, as that location for our river marinas is always in the floodplain. You know what? Dawn Gannier brought up a very good point. I'm going to bring something up here. Let me just, I don't know that it was in 555 though. Okay, Jason trip, but not on or in the structure. Yeah, it says the service equipment for a floating building, dock, or marina shall be located on and adjacent to the structure served, but not on or in the structure itself. That is true. So you want to get that out of that. But there's I think it's in 682. You got to look at this one, Dawn, because I will guarantee nobody is doing this. In 682, there is a requirement that says around services, I believe, here it is, 682.11 for you naturally and artificially made bodies of water people out there. It says, on land, the service equipment for floating structures and submersible electrical equipment shall be located no closer than 5 foot horizontally from the shoreline and live parts shall be elevated to a minimum of 12 inches above the electrical datum plane. Service equipment shall disconnect when the water level reaches the height of the established electrical datum plane. What that tells me is you need a float level out there, and you need it it needs to be programmed or set so that you have it established at the electrical datum plane, and when the water level gets higher than that, you need to kill the service. That I don't believe anybody has done. I've not seen it, and when I read that, I was thinking, boy, I don't know how an electrical inspector would make that happen. Maybe it's done at some of these wastewater treatment plants and things of that nature. I don't know, but suffice it to say, that is probably an area that I don't know if anybody is doing that. Okay, I see, Dawn, you put a note in there about signage. Should say no swimming. That is an issue with regard to outside the jurisdiction of the code. You can say raise the awareness of the hazard in that area. And we had a discussion about that today as well. So, but anyway, protecting, very economical solution if you want to put your protection at the service entrance equipment. But a lot of this is just talking about talking about protection at the head of each dock and how to lay out the system. There are various ways that you can do that. I put a picture here of a bender relay. You can field adjust these. You can set these to open an open shunt trip a device. Eaton has the digital ground fault relay as well, which can be used in these applications. With an integral CT. There's different ways you can wire the system. You can either loop feed these, where again in this case you're feeding one, which feeds another, which feeds another. You can put these in parallel. There's benefits for a loop. You can have the effective wiring method. It's more devices powered by a single circuit. The problem is, trying to pinpoint the device or devices that produce the leakage currents that cause the problem, because, it's a string basically. If one has a problem, you take them all out. Another approach, which is what we saw in that marina in Hilton Head, they went individual feeders to go each of these pedestals. So that helps it, that helps that if if that pedestal has an issue, that device trips. So, if I feed these on individual feed, and I call it a feeder circuit because there's usually a little power distribution panel in here. You have multiple receptacles, etc. So that's technically, I could argue that's a feeder and not a branch circuit to an appliance. But we can have that debate all day. I don't know, Dawn, what your thoughts are on that. But in any case, so the nice thing about that is you can identify the problem child and take them offline. You can put indicators out there. So this is a way that you can do that, single source monitoring, where you can put an indicator and know what's going on in the entire marina. The problem with this is, you have a low cost associated with that, but really you can take down the entire circuit, the entire marina. I haven't checked Facebook. Not aware of all these incidents. Yes, Mike, very sad. I appreciate you dialing in, buddy. All right, so this one here, high cost, multiple CTs can be expensive, but again, you don't have the impact of leakage. Bottom line is, when you lay out your marina, you've got to think about cost. You want to think about usability and livability in that marina. So when they have a problem, do they take the whole marina out? Marinas are money makers for some people. They don't want to take the entire marina because of one offender. So you'll typically have a feeder that goes out to that. You'll sometimes see multiple feeders. They'll supply a panel board out there. This is a panel board on the marina. You can see the water down the bottom. This panel board is on that docking station. or on the pier, and then they may put multiple panel boards, which drove a change in the 2020 cycle to recognize in 225 outside feeders. We made a change in 225 to permit multiple feeders to a structure, and we modified the definition of a structure too. I don't want to mix that definition up with car chargers, because I know we made a change to a structure or something that, man, maybe it was a scope that I want to make sure I'm in the right book. But we did change the multiple feeders to a structure so that you can pull multiple feeders. In this case, the pier would be the structure, and we wanted to be able to pull multiple feeders out to that structure. I'm just, for the life of me, buildings or other structures supply, number of supplies, 225.30. There we go. Man, it took me long enough. Don, you didn't throw the number in there. I thought you would have nailed it really quick. Common supply equipment, where feeder conductors originate in the same panel board, switchboard, or other distribution equipment, and each feeder terminates in a single disconnecting means, not more than 6 feeders shall be permitted. So I can now bring multiple feeders out to that pier. So if you think about it, even if I'm doing, if I'm doing that previous diagram where I'm landing, I'm starting on an overcurrent device, and I come into this equipment, there's an overcurrent device that I'm landing on. I can do something like this, up to 6 of these going out to a structure, where I can come from land out to that structure. But normally what happens is we bring these conductors onto the pier to a panel board, and then we go out to all of those pedestals. But I can bring multiple panel boards out there too to break down the circuits. Yes, Bruce, if a circuit ends in any form of overcurrent, it is still a feeder. If it ends in anything else, like an appliance or other utilization equipment, it is a branch circuit. I agree. That's perfect. So that it would depend on what you call that pedestal. If you call it an appliance, it would be a branch circuit. If it's a panel board, which I would almost liken that to be a panel board, because we have a breaker in there. We have multiple breakers in there. We have receptacles in there. I'm not sure how I would handle that one yet. But either way, we made some changes to accommodate that. We have multiple feeders going out to these locations. You'll see conduit and raceway out there, and that panel that we picked up, these are cement pads, and you can pick any one of those up, and you can see all of the wiring that's underneath. And you'll notice, these are providing shore power that, if installed today, would not meet the National Electrical Code requirements that we see in 555, because it's mandated that you use Marina power pedestals in those locations. They removed other than floating buildings, and that was in the 2020 in 90.2 scope. So other than floating buildings, because that was an issue. You said, what's not covered, ship other than floating buildings, railways. So we removed that out because it is back there in the back. In 90.3, 1 through 4, we already talked about that. We already said you've got to be mindful of 210.8, other than dwelling units and in dwelling units, because the marinas, I could have a boat dock in a dwelling unit area, multifamily, single family dwelling units. I can have it in other than dwelling units. We moved boat hoists back to 555 because that's where it makes sense. So we still have the GFCI requirements, but we move those back to 555. Now, be mindful that we expanded beyond 15 and 20 amps in A and B. In A, it's any circuit in those areas. In B, it's any of the circuits that are up to 50 amps single phase, 100 amps three phase. So, we moved single phase up to 50, and then three phase up to 100. And other than dwelling units. So other than dwelling units, all of these locations, you may have, locker rooms, you may have laundry areas in these marinas areas. So, that's an important thing to remember. So we consumed 553 into 555. We added a bunch of definitions in 555. The scope includes one family and two family dwelling units. We already talked about that. That was a 2017 change. 2020, we moved floating buildings in. Well, actually, we moved floating buildings into 555, where we're talking about floating buildings, and we deleted 553. Already talked about that. Where boats, floating buildings, and docks structures are connected to. So we added some informational notes. In 555.1, and that's where we noted that the text is extracted from 303. When you have extracted text, as I noted earlier, you cannot change any of that text. Very important to remember. So it's verbatim. And here's the examples. You look at this shore power going right down into the water. If this boat comes too close and rubs that conductor could energize the water in and around that boat. So, this has the ability to float and move in and out, up and down, and rub those conductors and cause a problem. And I mean, if you just go to some marinas, you will see more and more evidence of this type of wiring. You'll see this type of stuff that goes on. That's, a good friend of mine, Tim Cernko, educated me with a new term called ungood. That is ungood. Here's an example. Look at this. They tapped into this receptacle, and they actually put a plug unit on the other side, and so they're getting power from here, plugging it onto there to get more power. This stuff happens in these locations. There was a question earlier, what do I do when I go out to a marina? You're going to be looking for this type of stuff. Don't touch things when you see the MacGyvers and innovative solutions going on with regard to the installation. And a lot of this is, again, NFPA 303 talks a lot about maintenance and inspections, periodic inspections of these marinas. And when a lot of these documents like 303 are adopted as they piggyback onto other documents out there. So 303 tells us we should be looking at these installations because they don't last forever. We already talked about, and these are some of the definitions. I'm not going to be reading you definitions. I'm just telling you, we made all of these definitions. We talked about what berth is. We talked about what a boatyard is, bulkheads. I always thought a bulkhead, don't hit your head off the bulkhead when it was on a boat, but it's a vertical structural wall, stone, timber, metal, concrete, etc. Cranes, there are cranes and there are requirements for cranes. In 555.8, they talk about marine hoists, railways, cranes, and monorails, and there's requirements on what you need to do for those types of applications. Docking facilities. The electric datum plane, very important topic, very important for us to understand what the electrical datum plane is. A specific distance above a water level, above which electrical equipment can be installed and electrical connections can be made. So we want to be above the water level, and if you're on a floating dock, you're sure to be above the water level because you're floating. If you're on a fixed pier, that means you're fixed inside. That means you're not raising and lowering that pier based upon water levels. And things on shore, ground does not go up and down based upon water level. Last time I checked. The water level is going to encroach on Earth and pull away, and you can typically see the water lines across maybe even on some of the structures or on some of the posts or on the earth where the water line comes up to and where it recedes to. So understanding what you can and can't do. So 555.38 talks about floating piers. Remember, that floating pier goes up and down. You need to be 12 inches above the deck of a floating pier for any of your electrical equipment. So yes, that pier is going to be floating up and down, but you're going to want to be 12 inches above that floating pier, which goes up and down. Fixed piers, you have to be 12 inches above the deck, and you cannot be below the electrical datum plane. And then they added replacements. But now let's talk about that datum plane. How do you know the water level in your area? And I would offer that your electrical datum plane, if you just Google FEMA floodplain, there's flood mapping, and I was some jurisdictions are, and again, this will be up because it's not in the National Electrical Code. The National Electrical Code doesn't tell you where do you establish and how do you establish that floodplain value, and it's debated on what I want to use. FEMA, the numbers and levels from FEMA, it's argued by some that these are unrealistic numbers, that they will be way high, that you'll have receptacles on pedestals, sticking way up in the air that are not usable, or not be able to put certain service equipment anywhere near the water at all because of where those floodplains that FEMA has established. I did note that, I think I can go to history. Hold on. There was also, recently closed. I guess I can't look at my history. There's other, I think it's Minnesota. We'll call it datum plane. I believe it's Minnesota. What they do in Minnesota is they came up with their own way to recognize those datum planes, and I don't have that access at right now. But I'll just say that you got to remember that establishing where that water level is that you need to be above for those fixed piers from a datum plane perspective can be a chore. And if you pick the wrong number, it could be very expensive. But check with your local jurisdictions to find out if in the state that you're in, they may have defined that, because if there's any type of marinas going in, your electrical inspectors or your inspectors for those areas have struggled with what is that number beyond which you have to be 12 inches above the deck and not below the datum plane. What is that number? And how do you determine what that high water level is? So, and then they talk about, replacements. You have to be 12 inches above. So receptacles have to be mounted not less than 12 inches above the deck surface of the pier and not below the electrical datum plane on a fixed pier. So you have to understand what a pier is, and that's a float. It's something that's out there into the water. Access to the water can be a fixed or floating. We already know a fixed pier is what it is. It's fixed in place. It does not rise and fall with the water level. A floating pier rises and falls with the water level. Now, in land areas, so in Article 100, we talk about electric datum plane distances. The electric datum plane shall consist of one of the following. In land areas subjected to tidal fluctuations, the electrical datum plane shall be horizontal plane 2 foot above the highest tide level for the area occurring under normal circumstances. That is highest tide. So you're going to be looking at tide levels. You're going to be looking at flood levels. Highest water level for the area occurring under normal circumstances, 2 foot above that. What is that number? What is that water level under normal circumstances? Those are things that you're going to be going to either FEMA or other areas. And this is an area that presents challenges for electrical inspectors. For floating structures installed to permit rise and fall, there's that are equipped that can be rise to the plane 1 or 2 above, all that good stuff. So this is just talking about the distances for those types of installations, 12 inches above the level of the deck. So in one of the installations that I was on, we were doing the measurements to see where they were with regard to that. And then, how far off the water I was curious about how far off the water we were. And then on that pedestal, on that wooden structure there was, I didn't get a picture of the equipment that was on the receptacle or not. So, there's an example of a floating pier that goes up and down. Anything on this pier will always be above the water as long as it doesn't exceed that angle of the rise. And if it does, run, right? Go find the ark. In any case, that's just another shot of that. You'll see all of that equipment is floating buildings. So we came up with some definitions of marina power outlet. That's basically a marina power outlet. It has water on it in some cases. It has all your power for your boat. It'll include some critters. I learned what dirt daubers were when I was on this inspection. And I also learned that you want to be careful when you lift those lids. Literally, I mean, there's wasps and all kinds of stuff. You can tell what has been accessed and what has not been accessed. You've got the MacGyvers going on out there. They will do stuff to those pedestals. Some of them have been hit. You've got this stuff. You can't make this up. I can't make this up. It exists. This is why we lose lives in and around marinas, unfortunately. All right, so Don Ganir says our city code requires 2 foot above the 100-year flood line for equipment on land. Only your problem is that 100-year flood level seems to occur every year now. That's exactly right. It's getting worse and worse. We call that global warming, right? So power outlets, that is a UL 231 device. There is QPYV is the category code. That you can go out to the UL's, I forget what they call it now. It's not the white book anymore. I don't know what the name of it is. I'll put the link down below. You can take a look at that. Power outlet fittings. So there's a lot of stuff in this category code that's available on product spec or Q spec or product IQ. There it is, the product IQ. That I will put down below. A lot of this came right out of that product IQ document or product spec. Again, most of them are intended to be mounted. There's a pedestal type. Again, unless marked otherwise, a mounting post, pedestal, or fitting is not intended to serve as the sole support of the mast for overhead wiring. So I'm not going to get into all the details. You can pause this video and read this. I'm not going to spend a lot of time on it if you just don't want to click on the link down below. All right, so this is use and installation. I got a lot of details in and about that, about the power pedestal that I probably don't really need to have in there. So let's see where we want to go next. Let's talk about, there you go. There's a doozy for you, If you're walking on that pier and you see stuff like this, that could definitely be a shock hazard. We're not designed to be wrapping these things with what do you call duct tape, right? And this is called dual wasp nests. You have to special order these. We don't make these standard at the factory. In fact, we can't make these. These are created over time due to no or zero maintenance. You need to be performing maintenance on these things. If you're a contractor that is involved with marina type applications, get a contract together with your marina to go out there annually and inspect per NFPA 303 these pedestals and the infrastructure. In 555, in the 17th cycle, they raised the voltage level should not exceed 1,000 volts phase to phase on the pier. In the 2020 version, the maximum voltage is 250 now. So pier power distribution systems where qualified personnel shall be permitted to exceed 250 volts, but these systems shall not exceed 600 volts. So we moved that back down to 600 volts in 555.5. You know, what happened in the 1,000 volts, they moved that 1,000 volts up. I mean, it was like a search and replace effort for when we went from 600 to 1,000. And you know what drove that? The alternative energy solutions. They moved all of their stuff above 600 volts. They got rid of the inverter in those. They got rid of the transformer in the inverters. They had to pump that up. So in 555.5, we basically brought that back down again to 600 volts. We said, you know, it just doesn't make sense to have a pier that has that type of voltage on it. This is just a label. But in general, so transformers, so you would think the primary of a transformer is probably what you would be serving. And if you are above 1,000 volts, if you're coming to 4160 on a pier, you don't want to be doing that. Now, remember too, that that these requirements even apply when you bring those marinas that house the what do you call those? What do you call that when you get on a big boat and you go surfing all over the place? Not a tour. What do they call that? You're going on a cruise. Jeez. When you got a cruise ships, you know, those marinas that house cruise ships are also fall under this. But still, we had that into consideration, and you're not allowed to have more than 1,000 volts on the way we wrote it. On power distribution system shall not exceed 250 volts face to face. Where qualified personnel service the equipment under engineering supervision, they are permitted to exceed 250, but not 600 volts. And in that decision, we did consider those big boats, and they are powered at typically around 480. They're not 4160. They don't take medium voltage onto those boats. So there's no reason to get 480 out there. And in this requirement from a transformer perspective, we said, you know, you can put transformers out there. They have to be listed for wet locations, you know, identified for wet locations. We didn't say listed for wet locations because I don't know that you can buy a transformer listed for a wet location unless it's in an enclosure, right? And then the closure is listed for wet locations. So I think that they can be identified for wet locations. And the bottom shall not be below the electrical datum plane. And then again, you know, we handled replacements. And you know, I was talking to Donnie Cook, and I'm like, who in their right mind would do that? And Donnie sent me a picture of an example where they have a transformer out there. And I said, all right, you know, it happens. So that's a good example. This is the Cunningham, where the Marina that had where the Cunningham lost his life, and they redid all of that. They talk about the location of service equipment, that it can't be placed in that location. You know, we were doing our class, our training class. That's Jack Jameson right there. Very good man. I can't say enough about Jack. Love him dearly. He's a good friend of mine, and he does so much for the electrical industry as others do as well. But in any case, we had a training core class on this, and this was that, remember that wood pedestal? I said there was equipment, and we were doing the measurements. There's the conduit that came up around the back of that, and there was a light on top of that. And most of the people were looking at the enclosures and how they were serving power to these piers. So this is, you know, again, this is an example. This is onshore. And there are requirements now in 555 that deals with overhead conductors that go down to the marina. So this is an example of overhead conductors that serve a pier. And there's another shot of that where they come up and out. And, you know, this is actually a station where they have propane. This brings in another issue. You know, the fact that chapters 1 through 4 apply generally, and 1 through 7 can amend 1 through 7. You know, there are HAZLOC locations on top of these because we've got fueling stations, you've got propane stations, things of that nature. So you have hazardous locations in addition to your standard requirements. 84 circuit panel, you still have the 6 means of disconnect on the dock, which allow turning off all power to the dock. Yes, Bruce. each of those 6 disconnects. So I'm not sure what's going on the comments on YouTube, but interesting discussion you'll want to stay in contact with. Transformer rules in part 1. So it requires a transformer installed inside the floating building to be identified for use in a wet location. You are right, Dawn. That is right. Because that floating building probably may sink someday. And we want to make sure that we can bring that transformer back alive. No, can't recondition transformers. Don't do it. And each of those panels can feed more panels. Yes. If the dock was allowed only 6 disconnects, you could only have 6 shore power pedestals on the entire dock. That is true. All right, I see that. Okay, I see we got it. This is what I love about the chat session on YouTube. You can read through there, and I could probably just focus on that, but I got to get back to this. So, and this is in the Marina area where we have this installation. So, you're going to have to put the marking of available fault current. So this is your maximum fault available current. I think that's the way Alabama does it. But that is, telling you that you have 4,941 and the date that meets the National Electrical Code requirements. So you still have to follow the rules in 110.24 for marking of available fault currents in those locations. 555.31, securing and supporting electrical equipment enclosures installed on piers shall be securely and substantially supported by structural members. So these are examples that you got to be mindful of what you're installing that on, and it's got to be substantial because this is an area that degrades over time. This is a panel that that has seen a lot. It's all rusty. The hinges are rusty. The structure that it's supported by was rusty. Here's another one here. You've got to close all of those openings. When you remove circuit breakers from these panels, you've got to cover those areas, because that's just a very important thing that you can get all kinds of things in there. People can stick their fingers in there either by mistake or on purpose, right? Just what the heck is in there? You get kids exploring, etc. Circuit breakers and switches installed in gasket enclosures arranged to permit required manual operation without exposing the interior of the enclosure. Again, arranged with a weep hole discharge condensation. Right? So there's special requirements for circuit breakers, switches, panel boards, and Marina power outlets. All such enclosures shall be arranged with the weep holes. General lighting and other loads shall be calculated in accordance. So this is the load calculations. You've got to, again, you remember 220, Article 220 has our load calculations, and there is references back there to the load calculations, but you do have to do your load calculations. Make sure you can serve the load that's on that marina. And there's demand factors in here, and they'll tell you that those demand factors may be inadequate in areas where it's extremely hot or cold temperatures, because you have heating and air conditioning and possibly refrigeration equipment where? On the boats, right? You saw that one air conditioning unit and a freezer on that one pontoon boat. So you got to be mindful that this stuff is going on inside, in and around those marinas. Just to give you some photos, these are faults that were found in that was in the water, right? So there was a cord just hanging down in that water, and it wasn't green because it was grounded. That's just green water because it's green water. In any case, so there's a lot of areas in and around these marinas that just demand attention with regard to the proper products and solutions and the electrical hazards. These solutions were listed and they were good up until the code made changes. But there's no proper fittings on some of this stuff. You've got to think about, here's a nice installation. I can't remember what this was here for the life of me. Cannot remember. But in that same installation, as I walk around, I'm looking and I'm seeing conduit raceway that's been pulled apart. In this case here, this was a raceway, and that's metal, and you think things are moving, and that's going to chafe and it's going to rub up against those conductors, and that is how we energize docks in and piers in marinas. All right, I'm just looking at the equipment grounding conductor. It has to be so. There's a 555.37 talks about the AGC. Tells you that you have to have to be what has to be connected to an equipment grounding conductor and run, and then it has to be run with the circuit conductors in the same raceway, cable, and trench. Tells us that it has to be an insulated conductor, green with one or more yellow stripes. So these conductors in these the equipment grounding conductors are going to be insulated in this area, and it shall be sized in accordance with 250.122, which is a good thing. So it's pointing us back to 122. Insulated equipment grounding conductor for branch circuits shall terminate at a grounding terminal in a remote panel board or the grounding terminal in the main service equipment. Talk about the feeders. Feeders supplying a remote panel board. Insulated equipment grounding conductors shall extend from the... So, and I on one of the inspections, we made certain to go and lift some panels and look for those green. If you're inspecting these areas, you're going to be looking for the insulated equipment grounding conductors. They have to be out there. You have to, and there's some discussions about the grounded conductor. Insulated conductor identified in compliance with 200.6, connected to the equipment grounding terminal at the service. So a lot of this is what we currently do already in regard to many installations. All right, so we're coming up on our 4:30 mark. I'm just going to look and see if there's anything else that I want to raise your awareness to. I already mentioned this. Motor fuel dispensing stations, hazardous classified locations, 55.11, they reference you back to 514. There are HAZLOC locations 1 through 4 applied generally, and you'll find these in and around that marina, whether it be on the water or not. You can see our pier in the back, and you've got locations like this, and that was an emergency stop, and then there was a siren. That's what some of that stuff was. And here's the pier that we had a nice good audience of ducks that wanted to come in and listen to our presentation and discussion. But Jack Jameson was sitting there, and he was talking about HAZLOC locations on marinas. And this one here had the disconnect as required in those locations as well. And that was your emergency fuel shutoff. All right, we are at our 2 hours, and what I will do now, I'm just looking at some pictures. I'm going to see if there's any doozies out there. I pretty much got through, I think, everything that I really wanted to get through, and what we will do now is go back to the stage, and I am going to do 3 and Menti out. 856823 is your Menti code. And as I'm looking at that, you can sign out at the Menti code at 856823. I'm going to focus my energy right now on the live stream chat. I just want to see what was going on out there. Dawn, looks like Bruce B. Bruce B, what's your last name, buddy? It's Bruce B. BB. What do I call your last name? Let me know. I'd appreciate it. I'm not sure I know who you are, but I appreciate you engaging as you are, and it looks like you are very knowledgeable, as Don Gannier and others are in these things. All right, so it looks like as far as FEMA floodplains, we already talked about that. Each of those panels can feed more. Yep, I did this 45 years ago. Awesome. You treat the dock like a service entrance with 6 main disconnects. Hey, Mr. Lichtenstein! I got to tell you guys about the Lichtenstein story. He may be late, but he is worth the wait. He is the man. Thank you. John Clements, thank you, and thank you for your engagement. You're a part of the crew, buddy. Dawn, thank you for participating, and thank you, Bruce, for participating. The sign out is down below. Bruce Barton, awesome. I know. Okay, I got you covered now, Bruce. Beautiful. What else? So I'm gonna take a look. Oh, Jack Jameson, my buddy Jack is there. Excellent. And Luis, Diego Panchico, thank you very much. I appreciate you attending. I'm gonna take a look out. Not too much activity on Facebook, unless for some reason my Facebook connection doesn't look. Doesn't look it doesn't look like it's updating. It's probably because I'm using too much. I'm getting a new computer. Eaton is buying me a much faster processor, a lot more video memory, and etc. So I'm going to probably be doing a lot more of these. David and Diego and Don Ganir and Tom Lichtenstein and all of you guys, we're shelter in place. We are and remember, ShockWeek. So I've got my mugs. Sign up, register. I'm going to put your name in for possibly winning the serial number 1 ShockWeek official mug, a part of the Technical Social Distancing Network. I wanted to get t-shirts, and I might get t-shirts. You may see me in my next presentation with ShockWeek, because this is tomorrow. Tomorrow, I'm going to be with Jim Dollard, Local 98 Safety Coordinator. You're going to want to attend this session. We're going to be talking about all of the things that can be done before to avoid shock. And working space is going to be in there. We're going to be talking about all the different code requirements from workspace. We're going to be talking about code requirements around barriers. We're going to be talking about code requirements around barriers, working space, barriers, working space. What else? What is it? Distance, adding distance. What else? There was another one, labeling. Labeling things with voltages and things like that. What's energized? What's not energized? We've got I think a really good program you're going to enjoy, and we're probably going to come up with some really good design decisions that you may find of interest for you. Whoops, wrong one. Outro. No, I don't want to do that. Sorry about that. Almost. Let me focus. Nope. Forgive me here. Where does TD live? I want to do end. Where's the end? Standby. There's test. Main report. MCC end. There we go. All right. So, Marina safety, and that's not the right code. I got to get back to my other scene. Bear with me here. 3. There it is. 856823. All right. So thank you all for attending, and I appreciate your focus on electrical safety, and I know we share that passion together, because there are still 32 of you out there joining me in the middle of the afternoon on a what is it today? A Wednesday. So thanks for the likes on that. Please leave any notes down below. Check back. Remember to subscribe to my channel. If you're on this channel already, subscribe, please. That helps out just to get MCC ended yesterday. Marinas just now ended. Yes. So awesome. Mathur Abbasi. Thank you for joining us again. And Bruce, thank you. We will keep this up. And I am going to be reaching out to my product line managers and try to get more diversity in providing some more materials. I like when I have people. Maybe you'll see a Lichtenstein in the future, or a Jeff Fecteau from UL in the future. Maybe Larry Ayer from BizCom Electric in the future. There are a lot of, and if you have a topic that you feel passionate about and you want to work on a presentation together, please let me know. I would love to do that with other people. All right, so sign out. You've got the sign out. And I'm just going to say thank you for joining us. And thanks for all you do for the electrical safety in the industry. We're going to be signing off now. I don't think I have a meeting I'm supposed to be in right now. I know yesterday I had to cut out quick because I was on a call. So thank you very much, Alexis and Bruce and Mr. Abbasi. Hopefully I will see you, Mr. Abbasi. I don't know what's going to happen in January for the code panel meetings, but that will be fun. John Clements, thank you. Thanks everybody for joining in. I'm loving the dialogue. Absolutely love the dialogue, and I got to figure out why that chat, I can't see that chat online. When I said, I configured this so that it will let people see the chat. So I have enable live chat, enable live chat to replay. So I'm not sure why on some of my earlier ones or some of the last two, you can't see these chat sessions because there's a lot of good stuff in the chat. And Luke Grayhor was with us too. All right, everybody, thank you. Signing off for now. Thomas Dimitrovich with Eaton. Remember to subscribe. Please subscribe to the channel. Check back. I'm going to be posting more little tidbits of information that I might not do live. I like the live because it just gets me out there. I don't have to do the editing. All right, everybody, I'm signing off. Take care. God bless. Stay safe. And by all means, stay healthy. All right. Still on Facebook.